Hey, namaste everyone. Welcome to Ray Optics class. Already we have seen many things in Ray Optics and we are at the end of this chapter. Only the things left with are one is compound microscope. Simple microscope already we have studied. We have seen it in while forming the images in a convex lens. We have seen simple microscope and the object is within the focus. Next we are left with compound microscope, telescope, their magnification formulas. That's the only part which is remaining. But before going to that part, we will solve some of the questions here, problems especially. And we have come across very important formulas like lens maker's formula, combination of thin lenses, refraction at a curved surface, and so on. We have completed mirror formula, and we have completed refraction at plane surfaces, Snell's law, and we have completed prism and everything. Now, suppose we can recall the formulas related to the lens and the refraction at a curved surface. It will be like this. So, lens formula, it is not lens maker's formula. Lens formula 1 by f is equal to 1 by v minus 1 by u, and the magnification in the case of a lens m is equal to h dash by h is equal to v by u. We had negative here in the case of mirrors. Magnification formula was having negative in the case of mirrors, and there was no negative in the case of mirror formula. But here in the lens we have negative here, no negative here. And one more formula comes along with mirrors, that is f equal to r by 2. That doesn't help you here. That is not applicable for lenses. And lens maker's formula, power of a lens or reciprocal of focal length. See, how do I pronounce here? Refractive index of the lens by refractive index of the surrounding medium. I don't say n2 by n1. Refractive index of the lens by refractive index of the surrounding media minus 1 into 1 by r1 minus 1 by r2. This is another formula, and when the two thin lenses are kept in contact, the power gets added up. P is equal to P1 plus P2, but reciprocal of focal length gets added, and you know that reciprocal of focal length is the power, right? We don't have a power problem today. We have only image formation problems, right? And formation of a lens. Okay, these formulas are very important, and you should be extremely careful while substituting negative and positive sign conventions. That you should get experienced well with putting sign conventions, then you will get the confidence. Okay, now we will move on to the first problem. The first problem goes like this. Two convex lenses of focal length 0.3 meter and 0.5 meter are placed in 1 meter apart. An object is placed at a distance of 0.6 meter from the former. Former means first one. Which is the first one? This one. An object is placed at a distance of 0.6 meter from the former, from 0.3 meter lens. Find the nature and position of the final image. There are two lenses here. Now, sir, can we apply this combination of lenses formula? Find out the equivalent focal length. No, because they are kept 1 meter apart, right? Focal length 1 meter apart. They are not placed together. This formula for combined focal length holds good only when the lenses are kept in contact, touching each other. They are not kept touching each other. Now, if I can place two lenses, convex lenses, and moreover separated by a distance of 1 meter like this, and one of focal length 0.3 meter, I will shift everything to the diagram so that I need not read the problem again and again. If I shift all the data to the diagram, I will get it here only. So this is a lens of focal length 0.3 meter, this is of 0.5 meter, separated by 1 meter. An object is placed at a distance of 0.6 meter from the former. So from here it is 0.6 meter. This is object distance. Now my question is, here there are many possibilities of getting images. One is what we did in lens maker's formula. In the same way, one surface forming the image at one place, and that is acting like an object for another surface. Things may be so. Now we will see what happens here later. Now here, one thing can be concluded, that is, this is 1 meter, this is 0.6. Here you see focal length 0.3 meter. Can you apply all your knowledge here? Focal length is 0.3, object distance is 0.6. Is it double the focal length? When an object is kept at 2f, image will also be formed at 2f, you know this. That means image will be definitely formed at 0.6 meter. 0.6 meter comes within 1 meter. That means this forms the image before this lens itself. And there may be another case also. Suppose object is kept between f and 2f, then it goes beyond 2f. Suppose, so I will discuss the case. Suppose the object, this lens forms, I will take two rays of light like this. Imagine that the image is formed somewhere here. like this, and of course like this. First lens forms the image here. You remove the second lens, first lens forms the image here. Say it is at 1.5 meter like this. This is only my guess, right? 1.5 meter. Then this acts like an object for the second mirror, and that object distance is 0.5, because this is 1, this is 1.5, this is 0.5. This is one possibility. And of course finally this ray will be bent again by the second mirror and final image will be formed here. But for the second lens, this is the object distance, 0.5. That is one possibility. But here the possibility doesn't arise. Why? So there are many possibilities, because we know the theoretical explanation here saying that this is f, this is 2f, image is also at 2f. That means this lens will form the image here. What do you mean by that point? This is 0.6. We will prove it, because this is a theory problem. You can't keep on putting your theory and write the steps. By skipping the steps, write the answers. You have to show the steps. If this is 0.6, this is 0.4. Now this acts like an object. You ask this lens, lens 1. Lens 1, do you have any object in front of you? Yes sir, I have an object. How do you say that this is an object? Because I receive two rays, sir. And these two rays, when they are produced backwards, they come from point O. So definitely O is an object. You ask the second lens, are you receiving any rays of light? Do you have any object in front of you? Second lens says, yes sir, one ray like this and another ray like this. These two rays bent by this lens, these two rays, once they proceed, they don't take rest at the point where image is formed. They will continue. So they will continue like this, and then form the image. Now you see what is the fate of the second lens. Ask the second lens, are you having any object in front of you? Yes, there is an object, sir. What type of rays are coming from the object? Diverging rays, sir. What did you do? I formed the image. Where is the final image? So for the second lens, focal length is 0.5. Object distance is on the left side again for this lens. It is not on the right side. Something image formed by the object, first lens, somewhere here is not acting like an object for this. Image formed by the first lens here only, that is acting like an object for this. It comes in the left hand side. So we will keep on proving it. And of course, if you see the second lens, focal length is 0.5. Object is 0.4. What will be the condition? You can guess it now. So while solving optics problems, apply the theory knowledge as far as possible. Make sure that your answer is correct. So it gives confidence and you can move forward. Otherwise, if something is wrong, if theory and answer do not tally, then you will get an idea that you have gone somewhere wrong. Okay, so this 0.4 is within 0.5. Focal length is 0.5. Object is within focus. Where should an image be formed? Enlarged image should be formed on the same side, right? So you should get finally virtual image. Now shall we start one by one? So let us apply the formula for the first lens. Okay, this is only a guesswork, and now the situation is different. I want to get 0.6 as the image distance. For lens 1, I name the lenses as first lens and second lens. For lens 1, 1 by f is equal to 1 by v minus 1 by u. That implies 1 by f, focal length is positive for a convex lens, because if parallel rays are incident on a convex lens, they meet at a point here, at the focus, like this. They meet at focus, and that focus is on the right hand side, and that is positive. If you take the coordinates like this, so 0.3, v we don't know, minus in the formula, minus u is on the left hand side, minus 0.6, right? So if you solve this becomes 1 by plus 0.6, you bring it here. So shall I write it here? Yes. And okay, I can rub the formula, I can use it, because I am very sure that these formulas are printed in your brain. I am very confident that you know all the formulas within your brain. Okay, so we will write it later. 1 by 0.3 is equal to 1 by v plus 1 by 0.6. So 1 by 0.3 is equal to 1 by v plus 1 by 0.6. Bring this here. So shall I multiply and divide by 10? I don't like these fractions. I want whole numbers. 10 by 3 minus 10 by 6 is equal to 1 by v. That implies 6 is common denominator, and 3 2s are 2, 10. 6 ones are minus 10. So what is 1 by V? 1 by V is equal to 10 by 6, and that implies V is equal to 6 by 10. So you know at both the sides it is 0.6 meters. That means image is formed at a distance of 0.6 meters. Coming back to this side, I hope both these boards are available for you. This is 0.6 meters, and you got positive. What do you mean by positive value? Very simple. Image is formed on the right hand side. Real image formed by the first lens. Now that acts like an object for the second lens, because rays of light, they merge, produce the image, move forward. They don't take rest. They continuously keep on moving. Wherever they meet, they produce the image. So image is formed. That acts like an object. For the second lens, object distance is 0.4. So where will be the final image? Of course it should come to this side, because you know that 0.4 is within 0.5, within the focus, virtual image, simple microscope. So for the second lens, for lens 2 now, so for same formula, 1 by V, 1 by F is equal to 1 by V minus 1 by U. 1 by convex lens, focal length positive, no doubt, is equal to 1 by V, image distance, don't know, you should get it as negative now. We know that it should be negative, but now we can't put it as negative, minus formula minus object distance on the left hand side, 0.4 minus 0.4. So this is plus 0.4, multiply and divide by 10, 10 by 5, minus this one, 10 by 4, I will skip one step, is equal to 1 by V. So where will be the final image then? That implies 20 common, 5 4s are 40, 4 5s are minus 50, that is equal to 1 by V. I always write 1 by V, because there is a danger that you will skip writing 1 by V and taking this itself as V. This is not V, this is 1 by V. So that implies 10 by 20 is 1 by V. So what is V? V is equal to, here it should be minus 10, because 40 minus 50 is minus 10. So what is left with? Minus 20 by 10, it is minus 2 meters, because everything is in meters, nothing is in centimeters. 0.4, 0.61, everything is in meters. Minus 2 meters, what do you mean by minus 2 meter? On the same side, left side for this lens. For this lens it is left hand side. So how will you write the answer? So final image is virtual, final image is virtual, erect, and formed at a distance, of 2 meter from second lens on the left side, 2 meter from lens 2, on the same side as the object, that is what you have to write. So you should answer to their question, right? Where will be the final image formed, and find the nature, position. It is formed at a distance of 2 meter on the left side of this lens, or that means on the side of the object. From here it is 2 meter. So looks very simple, actually simple problem, but you must have a very good experience of substituting the sign conventions. Shall we move on to the second problem? Read the second one. Where should an object be placed? This problem. Where should an object be placed? Where should an object be placed? In front of a convex lens of focal length 20 centimeter, so that an image magnified 4 times is obtained. Only one sentence problem. Sentence starts, and by the time you get full stop, problem is over. No second sentence. At what distance from the convex lens of focal length 20 centimeters an object be placed so that an image magnified 4 times is obtained? Now the problem is here, whether it is real image magnified 4 times or virtual image magnified 4 times. Nothing is told. That means, sir, whether convex lens forms both magnified images, real as well as virtual? Yes, its virtual image is always magnified. It is a magnifying lens, convex lens. It is a simple microscope. When the object comes within the focus, the same sized, on the same side an enlarged image is formed. It's a simple microscope. Now, so the image may be real or virtual. When will be the real enlarged image is formed? When the object is between f and 2f, image is formed beyond 2f. That is real enlarged image. So, shall we discuss both the cases? Now, first of all, we write real enlarged. So, since it is not told, we have to take both the cases into picture. Real enlarged image, 4 times enlarged. Now, when it will be formed? So, here will be a convex lens, the principal axis, focus, double the focus, focus, double the focus. Take an object, and you know that when anything between f and 2f, f and c in the mirror is smaller, anything away from 2f is larger, whether it is object or image. There, anything away from center is larger. So, I will keep an object between f and 2f. One ray parallel to the principal axis passes through the focus. Another ray through the optic center moves like this. This is the enlarged image. So, this is real enlarged. And you know that this lens is having a focal length of plus 20 because it is convex. If parallel rays are incident here, you get the focus on the right hand side. Okay. But if you put the rays of light like this, then the focus comes here, but direction becomes this one. All the distances measured in the direction of ray of light are taken positive. But we don't change that opportunity of rays moving on minus x-axis. We just always take it another x-axis. So we don't want to lose the rays coming from origin to plus x-axis. We will take always like that. That's why object is kept here always. This is image. Okay, now. Magnified 4 times, but this is real, inverted. Since it is inverted, magnification is negative. This is enlarged and inverted. So, m is negative here. Magnification is negative. What is the magnification formula? M is equal to V by U, H dash by H. No negatives here, but in the lens formula you have negative with the U. U is negative. Okay, now M is V by U, H dash by H, right. Shall I use this formula? Minus 4, you know why it is minus? Inverted, right? Inverted image. Minus 4 is equal to V by U. That implies V equal to minus 4U. We got one equation. Now substitute this one here so that the whole equation becomes in terms of, our whole equation turns into U, 4U here, minus 4UU, so that focal length is given, U can be calculated. That is what they are asking. At what distance an object should be placed? So substitute V equal to minus 4U here. What happens to this equation? 1 by F is equal to 1 by minus 4U and minus U. Now can you guess and tell me what type of object distance you should get? Whether it should be on the left hand side or right hand side. Usually it is on the left hand side. U should be negative. You should get negative U. And another thing you can guess is, for a lens of focal length 20 centimeter, where should be an object so that image is magnified and away from 2f? Image is away from 2f and object will be between f and 2f. That means between 20 and 40. Your answer should be, object distance should be between 20 and 40. Let us check it. And it should be on the left hand side. U should be negative. So that implies 1 by f is equal to, can I take 4u common? 4u minus 1 times and u minus 4 times. This is minus 5 by 4u. And you know that, yeah, 1 by f is equal to minus 5 by 4u, and f is positive because it's a convex lens. I'll take f in 20 centimeters and u will be in 20 centimeters. 1 by 20 is equal to minus v by 4u. You bring it 4u here or u here and 20 here. What you will get? That implies u is equal to, only u here, 20 into 5 minus 100 by 4. What is u? U is equal to minus 25 centimeters. Is minus 25 centimeter coming to the left hand side? Yes, it is opposite to the direction of incident light. Like this. Is it between f and 2f? Yes, it is between 20 and 40. It is between 20 and 40. 25 is between 20 and 40. Answer is correct according to our knowledge, right? And sir, whether this is the only number that you get between 20 and 40, okay, you don't get many numbers like 30, 32, something like that. But still, if your calculation is correct, this answer is correct. Okay, but still you have some verification. Suppose you don't get, suppose you get 60, definitely it is wrong. One verification is possible. Okay, now we will see another possible case, because they have told an image magnified 4 times. What type of image not mentioned? So shall we take a virtual image? Of course, virtual is always enlarged in a convex lens. In a convex lens, virtual image is always enlarged. So how is that condition? It is like this. If you take an object in front of the lens, this is f and this is 2f, this is f and this is 2f. An object is placed within focus. One ray of light parallel to the principal axis passes undeviated. Another ray of light passing through the optic center, they diverge each other. For a person observing from here, he feels that these 2 rays are coming from a different point here. A different point here. This acts like the virtual image, enlarged on the same side. This is one other possibility. Focal length is again 20 centimeter. It is plus because the lens is this convex lens. Parallel rays get focused here, so that is on the right hand side. So no problem. Now, shall we use this? Now, which magnification you will substitute? Now magnification is positive. What do you mean by magnification positive? Both object and image are above the principal axis. Otherwise, this formula will lead to some other problem. If V is negative and only V is negative or only U is negative, magnification will be negative. That means either object or image should be below the principal axis. Now both are above the principal axis. So shall I take it as plus 4? 4 times the image is formed. So what is V equal to? 4 is equal to V by U, V equal to plus 4U, one case. Now take the lens formula, substitute it in the lens formula. 1 by F is equal to 1 by V minus 1 by U. What else? 1 by 20, let it be in centimeter. 1 by V minus, as usual, V you can substitute, V equal to 4U, V equal to 4U minus 1 by U. And as usual, U is on the left hand side. U must get U negative, no doubt. Then that implies, so shall I take it here? 1 by 20 is equal to 4U common, 1 times 1 minus 4 times 4. That is equal to minus 3 by 4U, right? So now 1 by 20 is equal to minus 3U by 4. Now keep U itself here, 4 here and 3 here. What you will get? U is equal to 1 by F is equal to 1 by V 4U minus 1 by U, object distance, yes. Then 4U is common. 1 by 20 is equal to 4U 1 times, 1 times, U 4 times minus 4 and minus 3U by 4 minus 3, right. Here, right, yes, it is gone wrong. Minus 3 by 4U. U should come to the denominator. So what is the next step? Yes, this is right now, right? This is right, minus 3 by 4U. So 1 by 20 is equal to minus 3 by 4U. So U bring it here, 60 by 4, but with negative sign. U is equal to, that implies 4U here, U here, this is minus 60 by 4, right? That is equal to minus 15 centimeters. So what do you mean by minus 15? Whether it comes within the focus, minus 15, minus to this side, 15 within 20 centimeters, definitely. So object should be placed either at 15 centimeter from the lens or at a distance of 25 centimeter from the lens on the left hand side, or anyway, no problem. Then you will get once magnified virtual, another time magnified real. So that is the answer to this question. So place the object at either 15, get the virtual image magnified 4 times, or at 25, get the magnified real image 4 times. So very beautiful problem. You will come across all the types of possibilities here. Now, shall we move on to the next one? That is a very important problem. Two Plano convex lenses. Two Plano convex lenses are placed with their spherical surfaces touching each other. Okay, so you will have Plano convex lens, one side plane and another side curved. They are placed with their spherical surfaces touching each other. The space between them is filled with water of refractive index 4/3. Refractive index of the material of the lens is 3/2. Radii of curvature of the surfaces is given 0.2 and 0.25. Find the focal length of the combination. Yes. Now, Plano convex. How will be the Plano convex lens? Plano convex. It will be like this. Right? This is the Plano convex lens. Plano convex lens. Now, when you take a Plano convex lens, you see this one, this surface. Try to find out the curvature for this surface. If you go on producing this, they don't meet at all. So the radius of curvature of this is infinity. What about this surface? Of course, you will have a radius on this side, that is R2. R1 is infinity, this one, this surface, R2, there is a surface. Of course, if it is like this, there is R1, but there is no R2. R2 is infinity, very large radius. So any plane surface is considered to be a part of a sphere whose radius is infinitely large. Take R as infinity. Okay, now two Plano convex lenses are placed with their spherical surfaces touching each other like this. It should be like this, spherical surfaces. Okay, it's like this, one Plano convex like this and another Plano convex like this, with their convex surfaces touching each other, bent surfaces, and the space between them is filled with water of refractive index 4/3. So I will fill this medium here, and it is water of refractive index 4/3. So this is 4/3, and this is 3/2, and this is 3/2. And the refractive index of the material of the lens is 3/2. Radii of curvature of the surfaces is 0.2 and 0.25. This is 0.2 meters, and this is 0.25 meters. Nothing else has to be substituted, right? Yeah, radius of curvature of this is 0.2, radius of curvature of this is 0.25. The material of the lenses is 3/2, middle in between liquid, that is water, is 4/3. What is the focal length of the combination? You know this formula, focal length of the combination is 1/f1 plus 1/f2 plus 1/f3. That is the reciprocal of the focal length of the equivalent lens. But you must know that if there are 3 lenses in combination like this, this is the formula for the equivalent focal length of single lens, which will act like these lenses. For example, if you keep an object and the image is formed here, this lens alone will form the same thing. That is why this is called equivalent lens. Its focal length is here, individual focal lengths are here. But what about these individual focal lengths? These individual focal lengths are the focal lengths when they are kept in air, not when they are in the combination. Now that problem arises when you substitute for the formula of lensmaker's formula. It is the lensmaker's formula goes like this: 1/f is equal to refractive index of the lens by surrounding medium minus 1 into 1/r1 minus 1/r2. So when you come across this refractive index of the surrounding medium for this lens, will you put the surrounding medium as this one? No, because f2 is the focal length when it is alone in air like this. When you take it in air, this is f2 here. So you need not worry about the surrounding medium now. So you will come across that problem when we apply this formula. So individually, if you know the focal length, you can find out the focal length of the combination. Individually, how will we find out the focal length? This one, because you know the refractive index of the material of the lens, you know the curvature and everything. This is the formula which gives the focal length. Now shall I write what is first lens focal length? I'll take this as lens 1, lens 3 and lens 2. For lens 1, 1 by f1, because f has to be found out using this formula. Combination focal length has to be found out using this formula. What is 1 by f1? 1 by f1 is equal to refractive index of the lens, 3 by 2. Oh, I will write the lens separately. I'll take it in air and I'll write it separately, otherwise it is a confusion. And this radius is somewhere here, and this radius is infinity. So this is infinity. Shall I take it as infinity r1? Because if you see this surface, light falls on this surface first, and this is not getting completed. It's a part of a sphere whose radius is very large. What about this one here? This is coming on the left hand side, this side. This is infinity coming on the right hand side. This is given 0.2. This radius is given left side. This radius is infinity on the right hand side. So 1 by f is equal to refractive index of the medium of the material medium of the lens, 3 by 2, by surrounding medium is air. Don't take it as water. It is the focal length we are finding out of this lens when it is alone in air. So air is here. This is occupied by air. 1 by refractive index of the lens by surrounding medium minus 1 into 1 by infinity first surface on the other side, radius infinity, or this side, whatever it is. For this one, it is on the left hand side, minus in the formula by, since this is on the left hand side, another minus first surface. Hope you have followed this. This surface is facing to this side, its center is here. So if you are moving in this direction along with the ray of light, distance for the center to the surface, that is radius, has to be measured like this. So minus 0.2, minus in the formula, minus contribution from sign convention. So what is this answer? 1 by f1 is equal to 3 by 2 minus 1 into 1 by infinity 0. This is plus 1 by 0.2. Okay. Now what is the answer finally? 1 by f1 is equal to reciprocal of the focal length of the first lens. 2 common. This is 3 minus 2. 2 ones are, 1 twos are. Shall I write it as 10 by 2? Multiply and divide by 10. It is 10 by 2. What is the answer? This is equal to, or that implies 1 by f1 is equal to, better you write all the reciprocals always. This is 1, this is 10, 10 by 4. Is it okay? 3 minus 2, 1, 1 into 10, 10 by 4. So let it be like this. Of course, this is 2.5. Let it be like this. 10 by 4 centimeter or meter. This is meter, so this is meter. Everything is in meter because 0.2 is meter. So 1 by f is equal to NL by 1 minus 1, minus 1 into 1 by R1 minus 1 by R2. R2 is minus 0.2 and negative is here, and 10 by 2. Yes. Right, 10 by 4. This is one equation because we are going to substitute it here. Shall we take the middle lens, concave lens, and we got this as positive. 1 by f is positive, and if you want to write what is the focal length of the first lens, 4 by 10 is 0.4 meter. Plus 0.4 meter I got it. Sir, this plus 0.4 meter means this is converging lens. Yes, it is a convex lens. Maybe Plano convex, but still it is converging. It is not diverging the rays. Shall we take the second one? It is a concave lens. How is it? This is like this water lens, and its refractive index is 4 by 3 material, and the surface, this one is here, and its radius is 0.2 meter on this side. This surface is here, and this is measured in this direction. The center of this lies here. This is measured in this direction. This should be taken positive, this should be taken negative. This is from left side, this is from right side. Coordinate axes are like this. Shall we write the lens maker's formula for the second lens, concave lens? Finally, we should end up with the focal length for this one as negative because it is a diverging lens. Now this is air, this is air. Don't compare it with this one, right? Individually that lens is given a name and it is given a focal length. That is in air. That focal length we are finding it out. 1 by f2 is equal to, you know the formula, refractive index of the lens by surrounding medium minus 1 into 1 by R1 negative minus 0.2. There is no negative in the formula. 1 by R1 but negative from the sign convention. By minus, this is formula minus, by 1 by R2. R2 is in the right hand side, no negative from our side using sign convention, plus 0.25, because this is measured on the right hand side. This is measured on the left hand side, R1 for this surface. The center lies on the other side. Minus 0.2, this is 0.25, this minus is on the formula itself, and we have to solve it so that we will get 1 by f2. 1 by f2 is equal to 4 by 3 refractive index of the lens minus 1, 10 by 2 minus 100 by 25. Okay, so what is 1 by f2? 1 by f2 is equal to 3 common, 4 minus 3 here, and this is, which I will take it as common, 50 I will take it as common, 50, then this is 225s are minus 250, and 25 2s are minus 200, and what is the answer? 1 by f2 is equal to, this is 1 by 3, what is here? 50, this is minus 450, right? Minus 450, this is 1 by 3, okay. 1, 0 gets cancelled, 5, 9 times. What is 1 by f2? That implies 1 by f2 is equal to minus 9 by 3, that is minus retains here, minus 3, right? This is not 1 by f2, this is 1 by f2 is equal to minus 3. This is correct. 3 minus 3 is 9, minus 9. So 1 by f2. What is f2? f2 is minus 1 by 3. Okay, it is 0.333. So this is not needed for us. Of course, individual focal lengths, if they were asked, then you have to find it out. So this is 0.333 meters. We got it as negative. This is okay. Now we got second focal length. Now the last one, last lens. This lens. You may ask me, sir, it takes such a long time. Shall we spend such a long time for this problem in the examination? You need not, because once you solve many problems like this, you have plenty of problems like this. You will get experience and you will go fast. That's all. Now you got this negative. That is correct. This should be positive now. First surface, here you have to measure it in this direction. What is that? 0.25. Now this is the first surface, sorry, here. First surface for the last lens. It is here. It is like this. This is the last lens, and it is 0.25. What is the second surface? Infinity, right? R2 is infinity, R1 is 0.5. So let us write 1 by f3, third lens. Refractive index of the lens, 3 by 2, again glass. So here was a Plano convex, here was a Plano convex. In between you have water. 1 by f3 is equal to refractive index of the lens by surrounding media minus 1 into 1 by r1, that is positive, because on 0.25, it has to be measured on the right hand side, minus in the formula by 1 by r1, 1 by r2 minus 1 by r1, sorry, 1 by r1 minus 1 by r2, infinity. 1 by f3 is equal to, this is 3 by 2 minus 1, so I will write it directly, that is 1 by 2 into 3 by 2 minus 1, 3 minus 2 by 2 into, this is 1 by infinity is 0, that is 100 by 25 I will write, multiply and divide by 100. So what is this 1 by f3? That is equal to 25 4s are, and 4 by 2 is 2. This is 1 by f3, it is not f3. So 1 by 2, 3 by 2 minus 1, 2 common denominator, 3 minus 2, 1, half, and this is 100 by 25, this is 4, 4 by 2 is 2. So shall we come to the total focal length of all the combination? Then we will have to apply this formula. So total focal length of the combination is given by 1 by f is equal to 1 by f1 plus 1 by f2 plus 1 by f3. That is equal to 1 by f1. 1 by f1 is 10 by 4. Remember what we have got last time? 1 by f1 is 10 by 4, and 1 by f2 is here, minus 3 plus 1 by f3 that is 2 plus 2, correct? 1 by f1 is 10 by 4 and f was 4 by 10, that is 0.4, and 1 by f2 is here minus 3, and 1 by f3 just now we have got 2. So what is the answer of this one? That is equal to, so shall we take 4 as common? 4 common denominator, this is 10, this is minus 12, 1 4 and 1 4 plus 8. 10, 12, 8. This is the only focal length which is negative. 1 by f is equal to 10 by 4. Okay, here we have 4 common denominator. This is 18 minus 12, that is 6. 18 minus 12. 10 minus 12 is minus 2 and plus 6. What is f is equal to 4 by 6, and this is 0.666 meters. So that is the focal length of the combination, and this is the way in which you have to solve the problem. And there are different problems there. For example, a convex lens is taken like this and a glass plate is placed here, and the medium between them is filled with the water and it is frozen into ice. So you have two lenses, one ice lens and another Plano convex lens. What is the focal length of the combination? Such problems, plenty of problems. You have to cultivate the habit of solving such problems. You will get the idea, and that's how we have to solve it. And you should have a little bit of patience. At least you will get patience after solving this problem, even if you don't get the answer. So that is more helpful, and try solving all these problems. We will come in the next class with few more problems. There are different types of problems in this chapter. Only this much knowledge is enough. There is no extra thing you have to learn, even for entrance exam as well as theory exam. This much is more than enough. Only the thing is, all those points should be connected together and they should be applied to the particular problem. That's all needed. So you will have data distributed in your brain here and there. You have to connect it one by one as required by the problem. So with this problem we will stop. Keep on working out problems, and keep in touch with the theory, and look into different problems. And if you want more problems, I will send it. You can work it out. So be happy, keep cheering. We will meet in the next class. Till then, have a nice day and have a nice time. Thank you.